Hurry up and take your seat, boys. So, yesterday when we started our discussion on statistics, on inferences, we talked about the different career paths that you could take using a degree in statistics. Talked about the importance of having to collect that data. And what we're going to get into now, Cameron, hood off and sit. What we're going to get into now is talking about the different means of collection, or not today, but we'll talk about it tomorrow, is the different means of collection. But the methods of collecting things, we call them a survey. Okay. Thanks. So the survey, so there's different ways of surveying, different types of sampling methods that we can go about in order to make sure that we've got valid results for our interpretation. If we focus on our population, so the key word for our population, the key thing to have an understanding of your population, it's the big picture. So go ahead and write that down, that when we talk about a population, we're talking about the big picture, the main idea, the large group, or the whole. So that's an important thing to have an understanding of. When we mention the sample, what's important about the sample is that it's the smaller picture. But not only is it the smaller part, what's really important about it is it has to represent your population. That's the main idea, that it must represent the population. If it's not a good representation, then you're going to have what we call a biased sample. And we'll talk about that next week. So what I mean by a good representation of your population, when we vote, voting is basically a sampling of what the country wants or thinks would be a good president, a good leader for our country. Now, not everybody votes, though, is it? Right? Right off the bat, there are specific groups that are not allowed to vote based off of age, right? Are you allowed to vote? No, because you're not of age. So right there, part of our population is everybody that lives in our country. That's our population. But the people who actually get to vote or do actually vote, that's the sample. And not everybody is able to vote. If you're too young, you can't vote. Maybe you are a legal citizen, or not a citizen, a legal resident to the country. So, for example, my husband, when he first moved here, he was 15 when he first moved here from China, he's a legal resident, and he didn't become a citizen until he was 21. So, even though he was 18 at the time, at a certain point in time, he wouldn't be allowed to vote because he wasn't a citizen. So he became a citizen when he was 21. But even then, he still wasn't part of the voting sample because he chose to not vote. There's people here who are actual citizens that exercise their right to not vote at all. In fact, the majority of people in the country don't vote. So the sample is just a small portion that we're hoping is going to be representative of our population. And to be representative, you have to have a good variety. So I could not say that everybody who votes in California will get to decide who my president is. Because if we rely only on California, what party is always going to get nominated? Huh? Democratic. Okay, because they tend to be a blue state. A blue state. And if we were to go with maybe Missouri, Republican. Okay, so they tend to run red. If we were to go again with just Georgia, if we only let people in Georgia decide, it would be Republican. But if we simplify it down even further and only let people in Atlanta decide, that would be Democratic. Okay, so you have to make sure that you're getting a good variety. That's why we have a widespread groups everywhere. You know, even though Georgia tends to be a Republican state, you've got pockets in Georgia that run Democratic. So you want to make sure that you have it open and available for everybody to participate, even though not everybody does. That's what gives it a good and fair sample. Okay? What we're going to be doing here is we are going to be identifying which set is actually our population and which set is going to be our sample size. So if we look at problem A, dress code, my sets are students in middle school. Set B is 7th grade in middle school. Which one of those is my population? Cameron? Students in middle school. So students in middle school, that's going to be the population because it's the overall picture, right? It's including everybody in the middle school program. 7th grade students in middle school, that's the sample because it's a small part of the population. So that's our sample. All right, if I wanted to do a survey about favorite flavors of ice cream, I've got customers at an ice cream shop in a town versus residents of a town. Which one is going to be the population, Isabella? That's actually the sample because that's just a small portion of the people who actually live in the town, right? Not everybody that lives in the town can fit inside the ice cream shop at once. So the ice cream shop, the customers who are in there are just a small portion to all the people who live in the town. So the population is going to be that residents of the town. That's your population. And then the customers at the ice cream shop in town, that's your sample. Any questions about that so far? All right, let's go on to the next slide then. So I told you guys last semester when we were learning about our ratios unit that there was a portion that we were always going to be using for the remainder of the year, that there was a concept that it didn't matter, it was going to be used in probability, it was going to be used in percents, it's going to be used now in our inferences unit. Who remembers what concept, what math concept that was? Anybody? Starts with a P. Not probability. Proportions, thank you. So proportions, we're going to be using proportions, and in this portion right here, this is where we're going to be using it. When we have to make predictions, anytime you see something that's wanting you to make a prediction, you must use a proportion. So I want you to go ahead and make that as a footnote up at the top of your notes right here. That to make a prediction, you must set up a proportion. In order for you to make a prediction, you're going to set it up as a proportion. And you do your cross product to solve. Okay, so in this question right here, it says students in Mr. Blackwell's class brought photos from their summer break. The table shows how many students brought each type of photo. So for the beach, you've got 6. Campground is 4. The home has 7 photos, and theme park has 11 photos. So now we want to know what is the probability that a student brought a photo taken at a theme park. So we're focusing on the theme park. So to set it up as a probability, I need to know how many chose theme park out of the total. So how many chose theme park? 11, right? There's 11 people who chose to take a photo at the theme park. So the number of people from the theme park is going to be 11. And then we want to put it out of our total. So how many total do we have here? 28. How did you figure that out? You added them all together. Thank you, Yesenia. So you're doing 6 plus 4 plus 7 plus 11, and that's going to equal 28 total. So theme park out of the total is 11 out of 28. So there's our probability. The probability of choosing somebody who had a theme park photo is 11 out of 28. Now I want to use that probability in order to make a prediction. I'm trying to predict how many students might possibly bring in a theme park photo out of how many total? Not 28. Out of 560 students. So what I need to do is I'm going to take my probability. So that probability ratio that I just found of 11 over 28, I'm going to set it equal to what we call a prediction ratio, what I'm trying to predict. So we're going to set it up as x over 560. Once I have that set up, I can then use my cross product to solve it. So we're going to multiply 28 times x. And what's 28 times x going to give us? 28x. Okay. Then we're going to multiply 11 times 560. And what is that going to give us?
6,160.
6,160. Very good. So we have 28x is equal to 6,160. The last step to solving it is to divide by 28. Very good. So we're estimating, we're making a prediction that it's about 220 students that are going to have a theme park photo. Now, is that exact?
No.
No. Remember, it's just a prediction. Predictions are never accurate. Think about predicting the weather. Remember, we were supposed to have that snow on our snow day that we were out. Did we have any snow? No. But there was a 90% chance that it was supposed to happen. But as it gets closer, those predictions start changing. That probability is going to lessen a little bit. So this is just an estimate. It's never an exact value. Okay? Well, we're not in school tomorrow because that was supposed to be a weather makeup day, but we didn't have to make it up because we did a cyber day on the day off. Thanks. All right, so our next example. A survey found that 6 out of every 10 students has a blog. We want to know what is the probability that a student at the school is going to have a blog. So who can tell me how to set this up as a probability? The probability of a student having a blog. What is that going to be? 6 out of what? 10, right? We want to know how many students actually have a blog out of the total. And right now it states it right here that there's 6 out of 10 that have a blog. So there's 6 students out of 10. Now before I move on, I should always, always, always make sure I do what? Simplify. Thank you. So we're going to simplify, and that's going to give you 3 over 5, 3/5, right? Because they're both divisible by 2. Okay, so there's our probability. Our probability is 3 over 5. Now we're going to go down to part B where it says suppose that we've got 250 students at the school. How many would have a blog? So again, right there, that's a prediction that we're asking for. We're trying to make a prediction. So in order to make a prediction, I have to take my probability, which was 3 over 5, and then set it equal to our prediction, which is x over 250. Okay, so from here we're going to do our cross product. What's 5 times x?
5x,
5x, good. And what's 3 times 250?
750.
750, good job. Okay, last step is to divide both sides by 5.
And that's 150.
And that would give us 150. So we're estimating, we're making a prediction that about 150 students might have a blog. Yes. Not right now. Okay, what I want you guys to do is on the last page, I want you to do both problems 4 and 5 on your own, where you're going to find your probability so that you can make a prediction. And guys, if the probability is a percent, what's the percentage always out of? 100. Okay, so you're on this page then. Glenn, honey, you're not supposed to get out of your seat. Mm-hmm. Oh, here's yours.
It's not me, I promise.
It's not. I don't know how much.
It's not
If my phone is charging, I'm not using it.
Okay.
I know.
All right. Who can tell me for problem number 4, if you've got 85% people that were using emoticons, out of 2,450 students, how many would you expect to use emoticons? What do you think, Glenn?
So 100 times x, that's 100x, and 85, 200, that's 208,250. And if you divide by the 100x, that will equal 2,082.5.
But we're talking about people, right? So what should we make sure we do? Round. So it should be 2,083. Okay, so we've got 85%. Our probability is going to be 85% of the people that use it out of 100. So there's our percentage over 100. That's our probability. Now, it's not asking me for the probability, it's asking me to make a prediction. So I don't have to simplify that probability. If you did, that's fine, but it's not necessary because they're not asking you for the probability. They're asking you for a prediction. And the prediction is out of 2,450 students, boys. So you're going to set this equal, boys, you're going to set this equal to x over 2,450. Next thing that you're going to do is go ahead and do the cross product. So you're going to multiply 100 times x, which is 100x. Then 85 times 2,450, which is going to give you 208,250. Then to solve it, you would just divide both sides by the 100. And that would give you x is equal to 2,082.5, but as I said before, we're talking about people. So you need to have whole numbered values, so we're going to estimate it at 2,083. 2,083 students that we would expect to use emoticons. Okay? What about for problem number 5? Now, how many would we predict to not have a television in their bedroom? Anybody work that one out? You finished it? You have your final answer? What did you get?
I got 1,150.
Not 1,150. How many do not have a television in their room? 54%. 54%, right? That do not have it. So 54% do not have it out of 100%. We want to know how many would we expect out of 1,725, Cameron?
Well, the answer is 934.
932, good. So if we did our cross product here, if we did 100 times the x, we'd get 100x. If we did 54 times 1,725, we're going to get 93,150. And then, of course, the last step would be to divide it by 100. But again, we're going to get a decimal, but we're talking about people. So we can't have a decimal version for people. We have to estimate it and round it to 932. Any questions? Okay, so you guys are going to get a worksheet. It's basically a printout from the workbook that I'm not giving to you guys. I figure I'll just hold off to giving you guys the workbooks. But in this worksheet, or on this worksheet from the workbook, you're only doing problems 1 through 6, and then 9 through 11. Problems 1 through 6, and then 9 through 11. So you are not doing number 7, and you are not doing number 8.